Imagine a time before time existed, a moment so primordial that even the concept of time had not yet been born. There was no space, no stars, no planets, not even light. It was a void, an emptiness beyond comprehension. Then, in a fraction of a second, everything changed. A monumental event occurred. This moment, about 13.8 billion years ago, is what we call the Big Bang. It was the birth of our universe. It wasn't an explosion like we see on Earth with fire and debris. It was the rapid expansion of space itself from a tiny point, smaller than an atom, into a vast and ever-growing universe. Imagine something so small becoming so immense. This period of rapid expansion is known as cosmic inflation. It set the stage for everything that would follow. As the universe expanded, it cooled down, much like how a hot object loses heat over time. Think of it like blowing on a spoonful of hot soup. The more you blow, the cooler it gets. The more you blow, the cooler the soup gets. This cooling allowed for the formation of the first particles. As the universe cooled, energy began to transform into matter. Tiny particles started to form the building blocks of everything. This transformation from energy to matter is one of the most mind-blowing ideas in science. It's a process that still fascinates scientists today. It's like the universe's way of saying, let there be something. And from this something, everything we know began to take shape. And from this something, everything we see around us today would eventually be created. Galaxies, stars, planets, and even life itself. The universe expanded incredibly quickly in a tiny fraction of a second. It's hard to imagine just how fast this was. It's like a tiny seed suddenly growing into a giant pumpkin in the blink of an eye. This rapid expansion, called cosmic inflation, is important because it explains why the universe looks so similar in all directions. It stretched out any early wrinkles or bumps, creating a smooth cosmic background. After inflation, the universe continued to expand but at a slower rate. And as it expanded, it cooled down, much like the hot soup we talked about earlier. This cooling was crucial because it allowed for the formation of the first particles, the building blocks of everything we see around us. Without this cooling, the universe would have remained a chaotic soup of energy. Just a fraction of a second after the Big Bang, the universe was incredibly hot and dense. Imagine the entire universe squeezed into the size of a football stadium. It was so hot that atoms couldn't even exist yet. Instead, everything was a swirling soup of tiny particles called quarks, gluons, and leptons. These particles zipped around at incredibly high speeds, constantly colliding with each other. Think of it like a crowded dance floor with everyone bumping into each other. It was a chaotic and energetic time in the universe's history. But even in this chaotic soup, a remarkable process was about to begin, the formation of the first elements. Section 4. The first elements appear. As the universe continued to cool, the tiny particles in the hot soup started to stick together, forming the very first elements. This process is called nucleosynthesis, and it's like building blocks coming together to make bigger structures. During this time, the universe was a hotbed of activity, with particles constantly colliding and merging. The first element to form was hydrogen, the simplest and most abundant element in the universe. Hydrogen atoms began to appear everywhere, filling the cosmos with their presence. Then came helium, which is the second most abundant element. Helium atoms joined hydrogen in the vast expanse of space, adding to the growing complexity of the universe. These two elements, hydrogen and helium, make up almost all the matter in the universe today. They are the fundamental building blocks from which everything else is made. Tiny amounts of lithium and beryllium, two other light elements, were also created during this time. Though they are much less common, their formation was still significant. These heavier elements are much rarer than hydrogen and helium, but they play important roles in the universe. They contribute to the diversity of matter and the complexity of cosmic structures. The formation of these first elements was a crucial step in the evolution of the universe because it provided the building blocks for stars, galaxies, and even life itself. Without these elements, the universe as we know it would not exist. Section 5. Let there be light. For about 380,000 years after the Big Bang, the universe was a foggy soup of electrons and protons, a chaotic and dense environment. Light couldn't travel freely because it kept bumping into these particles, constantly being scattered in different directions. It was like trying to see through a thick fog, where visibility is almost zero and everything appears murky. Then, as the universe continued to cool, something amazing happened. The chaotic environment began to settle. The electrons and protons slowed down enough to combine and form neutral hydrogen atoms, a significant milestone in cosmic history. This event is called recombination, a process that fundamentally changed the universe's structure. With fewer free electrons to scatter light, the universe suddenly became transparent, allowing light to travel unimpeded. light could finally travel freely across the vast expanse of space, illuminating the cosmos. This is the light that we detect today as the cosmic microwave background radiation, a faint echo of the Big Bang, providing us with a glimpse into the early universe. After recombination, the universe entered a period known as the Dark Ages, a time of profound darkness. It was dark because there were no stars or galaxies yet, only vast clouds of hydrogen and helium gas, waiting for the next phase of cosmic evolution. But within these clouds, gravity was at work, slowly pulling matter together, setting the stage for the formation of the first stars and galaxies, the building blocks of the universe as we know it.